The Voigt Retarder VR115CT. The Voigt Retarder is an efficient, continuous braking system that brakes coaches and trucks economically, comfortably, and wear-free. This animation shows what a Voigt Retarder can do, how it works, and most of all, which advantages it offers when it comes to reducing operating costs and increasing safety and driving comfort. See for yourselves. The Voigt Retarder 115CT is an offline retarder located on the left rear side of the transmission. The retarder is driven via a step-up gear train. The rotor is mounted on a shaft equipped with a gear. This retarder side gear is connected to the transmission side gear located on the transmission output shaft. This step-up gear train provides a gear ratio of approximately 2. This means that 1 revolution of the prop shaft equals 2 revolutions of the retarder shaft, hence the rotor. This ratio allows smaller retarder dimensions with the same performance, but with reduced weight and therefore increased efficiency. The offline position of the retarder provides space on the opposite side of the transmission, which can be used for power takeoff interfaces. The Voigt Retarder 115CT is activated via a hand lever switch at the steering wheel or via the braking pedal. During this activation process, the electronic control unit of the retarder communicates with the vehicle brake management. How does a Voigt hydrodynamic offline retarder work? When activated via the hand lever switch and/or the foot brake pedal, the retarder receives an electronic input signal from the retarder control unit. The oil sump is supplied with compressed air. Oil, to be used as operating medium, is moved into the retarder circuit between the moving rotor and the fixed stator. Through its rotary motion, it accelerates the oil and builds up braking torque, and the rotor is pulled into braking position via a helical gear. The rigid stator redirects the oil and moves it back to the rotor. Result, the rotor, and therefore via the step-up gear train, the prop shaft, is decelerated. The vehicle is decelerated. During braking with the retarder, the kinetic energy of the vehicle is converted into heat and dissipated to the oil. Via an oil-water heat exchanger and the vehicle cooling system, the oil is then recooled. During braking, the engine does not burn any fuel. This means there is no additional combustion heat. This means that the cooling capacity of the engine is exclusively available for the retarder. Temperature sensors at the electronic control unit, ECU, monitor the system and therefore exclude the risk of overheating. After every braking operation, the retarder is drained and a spring moves the rotor back into idling position via a helical gear. The shifting of the rotor away from the stator prevents losses in the operating circuit. As an innovative partner for the development and production of hydrodynamic retarders, Voigt can offer genuine continuous braking solutions. Voigt, engineered reliability.